we have started with the third chapter of paper number 2, and that third chapter is basics of your computer organization. That is what we are going to study in this chapter. And we have already studied block diagram of computer system, block diagram of central processing unit, the architecture of bus, different types of buses which are used, and we have also studied register based organization of CPU. So these three things we have studied yesterday, and today we are going to study what is called as a stack organization. Okay, so almost all CPUs, they use a feature which is called as a stack. Stack is nothing but a type of memory. Okay, and this type of memory is last in first out type of memory, and it stores the information in such a way that uh, the last atom which is inputted will be first atom that is taken out. Okay, so this kind of memory which is used in central processing unit is called as a stack organization. So why this stack memory is used? Many times we are using functions in your programming. Also interrupts which are also called as exceptions. Those are also used in computer system, and both of these concepts, that is function and uh, interrupts, they require a special type of memory to store the context of the program. Okay, so this type of memory is called as a stack memory. So stack memory is used to store the context where CPU has left execution of the main program, and it has moved to some another address for execution because it encounters a function call in the program, or because it has to handle some exception while executing the program. So it has to change the program execution flow. And when program execution flow has to be changed, then the context where the main program has been stopped at a particular point where the function has been called or exception has been raised. So these two contexts, these two what we can say, these two types of signals, or these two types of concepts which are present in your CPU, they have to store the context of the program where the main program execution has been stopped. And that context of the program means at that time what was the address in the program counter, what are the contents of different registers at the time where the execution sequence has been changed. So this all thing has to be stored somewhere, because after execution of the function or after execution of the exception handler, the program execution has to be returned to uh, address where it has left the execution. Okay, so when it returns, it requires to retrieve the context of the program when it was running. So that context can be stored with the help of special type of memory which is called as a stack. And in this point we are going to study the stack organization. Okay, so generally in digital computers, stack is a memory unit. Okay, and this memory unit comes with a register which is called as a stack pointer. It is abbreviated as SB and SP. This stack pointer is a register which always holds the address of the top of the stack. Address of the top of the stack. That is very important. Okay. So generally in stack memory, two types of operations are carried out. One is insertion of element onto the top of the stack or deletion of the element from the top of the stack. So these two operations are to be performed uh, by using the stack type of memory. Okay. Two types of stacks have been implemented in computer. One is called as register stack and another is called as memory stack. Here you can observe what is called as register stack. Okay, so a stack can be placed in a portion of large memory or it can be organized as collection of finite number of memory words or registers. So here the stack which is implemented by collection of registers is shown. Okay, so here 64 word uh, are used here, 64 registers are used here, starting from location 0 to 63. Okay, so these 64 registers are used to implement the stack. So top address of the stack is 63 here. What is the top address of the stack? It is 63. So what the stack pointer register must hold? It must hold 63 if there is element in 63. But here in this case, as you can see, there is the element at address number 1, there is element at address number 2, there is element at address number 3. So elements A, B, C are present here. So here now the top element of the stack is 3. So address that can be held in the stack pointer here in this particular example is the 3. So always remember the stack pointer is a register which can hold the top address of the stack memory. So in the stack organization, apart from stack pointer register, you can observe two more things, and these two more things you can observe here is one is data register. So this stack pointer is used to hold the address, whereas data register is used to store the data. It is used to store the data. That means now your stack pointer is pointing to the top element of stack. Okay, so it stack pointer has address 3. So that is what you will come to know from this diagram. There are two flip-flops here which shows whether the stack is full or stack is empty. Okay, so when all elements have been added to the stack memory, then this full will be marked 1, and when all elements from this memory has been retrieved or deleted, then this empty will be enabled or it is made 1. So these are the two flags which shows the condition of the stack, whether it is full or empty. So stack implementation requires arrangement of the registers one over other. Here 64 registers are used and it requires stack pointer register to hold the address of the top element of the stack. Full flip-flop is used to indicate whether the stack memory is full. Empty flip-flop is used to indicate whether the stack memory is empty, and data register is used to store the value of the data when it is retrieved from top of the element or when it has to be added to the top of the element. So in between this data value is held by this data register. Okay, now let us move. So there are basically two operations which are performed in stack organization. These two operations are called as push operation and pop operation. Push operation is used to insert element onto the top of the stack, and pop operation is used to retrieve the element or to delete the element from the top of the stack. Okay, so suppose in this particular example, if we want to remove the top element of the stack, now top element as we have seen here, it is present at address 3 and this has to be removed. And when this has to be removed, what has to be done is the contents of stack pointer register must be decremented by 1 if you are going to delete the element from the stack. Okay, so if you are going to delete element C, then the contents of stack pointer will be decremented by 1. That means 3 minus 1. So 3 minus 1 is equal to 2. So now after deletion, your stack pointer will be pointing to address 2. Okay, now this will become your top of the stack. So when you remember this, when any element from the stack has to be deleted or has to be retrieved, then stack pointer must be decremented by 1. Okay, now what happens to the stack pointer when you are going to insert, the element onto the top of the stack? uh, Obviously the stack pointer must be incremented by 1, because if we want to insert, in this particular case, if we want to insert some element onto the top of the stack, means that we are going to add the element. Suppose if it is D, we are going to add this D at address 4. So as we are going to add this at address 4, initially your stack pointer must be incremented by 1. So initially it must be pointed to address 4, and then the push operation must be carried out. Then push operation must be carried out. That is, the element must be inserted onto the top of the stack. Okay, at a place equal to 4. Okay, so you remember during push operation the stack pointer is incremented by 1, and during pop operation the stack pointer is decremented by 1. So these are the things to be remembered. A meaning of push operation is insertion of element onto the top of the stack, or adding element to the top of the stack. A pop operation means retrieving element from the top of the stack, or deleting element from the top of the stack. Okay, so these things you must remember as far as your examination is concerned. Okay, now, as you can see here, one more thing which I want to explain here is that can you see how many bits are there to have number 63? 6 bits are used. When all these 6 bits are 1, it indicates that address is 63, and this is the highest address in the 64 element stack, 64 element stack, for example. Okay, now we cannot exceed the number of bits than 6 here. Okay, we cannot exceed the number of bit than 6 here. Now suppose if your stack pointer maximum limit reaches 11111, and if you are trying to insert one more element onto the stack, then what will happen? Then obviously the stack pointer will be incremented by 1 first. Okay, so 1 will be added to 11111. So 11111 plus 1 is equal to 1, 6 times 0. Okay, so here what happens? It can accommodate only 6 zeros. It cannot accommodate 7th one. Okay, so this is what is indicated by, stack is full. Okay, so when you are trying to increment 11111, then it is going to produce the result this, and obviously the contents of stack pointer will be all zeros, and your flip-flop, which is marked as full, will contain logic 1. It will indicate that stack is full. Okay, now similarly, when you try to decrement, when the contents of stack pointer are 0, 0, 0, 0, 0, then if you are trying to decrement this, then what will happen? So 0, 0, 0, 0, 0, 0 minus 1. If you are going to find it out, the result will be again 1, 1, 1, 1, 1. Okay. So here, as you can see, the 7th bit is 0, but all remaining 6 bits are 1. So this condition is called as empty condition. Your stack is empty. Okay. You cannot delete any more atoms from the stack. Okay, that is what is indicated. And this empty flip-flop is set to 1, indicating that stack is empty. So when 0, 0 is decremented by 1, the result produced will be 0, 6 times 1, and empty flip-flop will be set to 1. This indicates the stack is empty. Okay, so this is how the stack is full and stack is empty is indicated with help of these two flip-flops, empty and full flip-flops. Okay, so initially when you are implementing this type of stack memory, the stack pointer may be cleared to 0 and empty is set to 1 and full is cleared to 0. So initially when no item is there onto your stack, you remember this, when the item is not present onto the stack, the stack pointer has to be cleared to 0 and empty must be set to 1, indicating that your stack memory is empty, and full flip-flop must be cleared, that it must contain 0, indicating that it is not full. Okay, so if the stack is not full, so what condition has to be checked? If stack is not full, that means if full is equal to 0. If full is equal to 0, then and then only you can insert an item onto the top of the stack by using what is called as push operation. इथेपर्यंत सगळ्यांना कळलं का मुलांनो मी काय सांगितलं? आणि कळलं नसेल तर मला विचारा, मी तुम्हाला पुन्हा सांगते. बोला पटकन. प्रत्येकाने बोलायचंय. कुणाला काय नाही समजलं त्यांनी न लाजता न घाबरता विचारायचंय. म्हणजे मी तुम्हाला पुन्हा एकदा एक्सप्लेन करून सांगते. महत्वाच्या कॉन्सेप्ट्स आहेत, तुम्हाला कम्प्युटर मध्ये पण त्याचा यूज होणार आहे, हे लक्षात ठेवा. पुन्हा एकदा सांगते मी तुम्हाला, आता मराठीमध्ये सांगते की स्टॅक पॉइंटर नावाची मेमरी जी असते ती स्पेशल टाइप ऑफ मेमरी तुमच्या कम्प्युटर सिस्टीम मध्ये इम्प्लिमेंट केलेली असते. तर स्टॅक मेमरी कशी डिफाईन केली जाते, तर फर्स्ट इन लास्ट आउट, जो पहिला ऍटम इन्सर्ट केला जातो तो शेवटी डिलीट केला जाऊ शकतो, अशा प्रकारची जी मेमरी एलिमेंट्सची अरेंजमेंट आहे त्याला स्टॅक असं म्हणतात. स्टॅक म्हणजे एकमेकावर अरेंज करणे, एकमेकांवर ढीग अरेंज करणे. एकमेकावर ट्रे जर तुम्ही ठेवले तर काय होईल, शेवटचा ट्रे जो असेल तो पहिला तुम्ही इन्सर्ट केला, पण काढत असताना तो तुम्हाला शेवटी काढावा लागतो. शेवटचा ट्रे जो तुम्ही टॉप वरती इन्सर्ट करताय तो पहिल्यांदा काढावा लागतो, बरोबर आहे. मग अशा प्रकारची जी मेमरीची ऑर्गनायझेशन आहे किंवा अरेंजमेंट आहे त्याला स्टॅक मेमरी असं नाव आहे. आणि ही स्टॅक मेमरी जनरली फंक्शन जिथे कॉल करताय तुम्ही किंवा ज्या ठिकाणी एक्सेप्शन हँडल करायचे असतात अशा ठिकाणी ती यूज केली जाते. कशासाठी यूज केली जाते, तर ज्यावेळेस फंक्शन कॉल होतो तेव्हा प्रोग्रामचं एक्झिक्युशन जे आहे ते बदलतं, त्याचं ऍड्रेस बदलतो एक्झिक्युशनचा, तो फंक्शनच्या ऍड्रेस पासून स्टार्ट होतो. मग मेन प्रोग्राम ज्या ठिकाणी तुमचा थांबलेला आहे त्या प्रोग्राम त्यावेळेचा ऍड्रेस आणि त्यावेळेस जे सगळे कॉन्टेक्स्ट आहेत तुमच्या प्रोसेसरचे, म्हणजे सीपीयू चे सगळे रेजिस्टरचे कंटेंट्स आहेत ते सगळे तुम्हाला अगोदर सेव्ह करून ठेवावे लागतात. मग हे कुठे सेव्ह करून ठेवणार, तर हे स्टॅक नावाच्या मेमरीवर स्टोअर केले जातात. मग जेव्हा तुमच्या फंक्शनचं एक्झिक्युशन कम्प्लीट होतं तेव्हा शेवटची लाईन नेहमी रिटर्न असते आणि तुम्ही फंक्शन मधून मेन प्रोग्रामला रिटर्न होता. जेव्हा मेन प्रोग्रामला तुम्ही रिटर्न होता तेव्हा कुठे अगोदर थांबला होतात तो ऍड्रेस तुम्हाला लागतो आणि तो ऍड्रेस तुम्ही म्हणजे तुमचा सेंट्रल प्रोसेसिंग युनिट हा स्टॅक मधून घेतो आणि त्यावेळेस जे काही रजिस्टरचे कंटेंट्स होते ते सुद्धा तो काढून घेतो. ओके, मग ज्या वेळेस तो कॉन्टेक्स्ट स्टोअर करत असतो त्यावेळेस अगोदर तो रजिस्टरचे कंटेंट सगळे स्टोअर करतो आणि नंतर ऍड्रेस स्टोअर केलेला असतो, जेणेकरून पहिल्यांदा त्याला ऍड्रेस मिळेल मेन प्रोग्रामला रिटर्न झाल्यावरती. तर असे कॉन्टेक्स्ट जे एक्सेप्शन मध्ये पण स्टोअर करावे लागतात आणि फंक्शन कॉल मध्ये पण स्टोअर करावे लागतात, अशा प्रकारच्या ऍप्लिकेशनला स्टॅक मेमरीचा तुमचा उपयोग होत असतो. ओके, आणि स्टॅक मेमरीमध्ये दोन प्रकारचे ऑपरेशन होत असतात. एक म्हणजे एलिमेंट इन्सर्ट करणे, त्याला पुश ऑपरेशन म्हणतात. एलिमेंट डिलीट करणे, त्याला पॉप ऑपरेशन म्हणतात. हे लक्षात ठेवा. स्टॅक पॉइंटर नावाचा रेजिस्टर असतो आणि स्टॅक पॉइंटर नावाच्या रेजिस्टरमध्ये त्या स्टॅक मेमरीच्या टॉप एलिमेंटचा ऍड्रेस नेहमी स्टोअर केलेला असतो. हे पण लक्षात ठेवा. त्यानंतर स्टॅक मेमरीमध्ये दोन प्रकारचे फ्लिप फ्लॉप्स असतात, एक फुल आणि दुसरा एम्प्टी. जेव्हा तुमचा स्टॅक फुल होतो तेव्हा तुमचा फुल फ्लिप फ्लॉप हा 1 केला जातो, अदरवाईज तो 0 असतो. जेव्हा तुमचा स्टॅक हा एम्प्टी असतो, एम्प्टी म्हणजे काहीच नसतं त्याच्यामध्ये, त्यावेळेस काय केलं जातं, एम्प्टी जे आहे ते 1 म्हणून मार्क केलं जातं, अदरवाईज ते 0 असतं. त्याच्यावर एखादा जरी एलिमेंट असेल तर एम्प्टी 0 असतं. ह्या गोष्टी लक्षात ठेवायच्या. आणखीन एक त्याच्यामध्ये एलिमेंट असतो डेटा रजिस्टर. जेव्हा तुम्ही एखादा एलिमेंट बाहेरून त्या स्टॅक वरती इन्सर्ट करणार आहात तेव्हा तो अगोदर डेटा रजिस्टर मध्ये स्टोअर केला जातो आणि डेटा रजिस्टर मधून ऑन द टॉप ऑफ द स्टॅक, किंवा एखादा एलिमेंट जेव्हा स्टॅक मधून रिट्राईव्ह केला जातो किंवा डिलीट केला जातो तर तो टॉप वरून आधी डेटा रजिस्टरला जातो आणि मग डेटा रजिस्टर मधून जे काही तुम्ही डेस्टिनेशन तिथे प्रोव्हाइड केलंय त्या डेस्टिनेशनला तो जाईल. अशा प्रकारे स्टॅकच्या ऑपरेशन्स या होत असतात. हे लक्षात आलं का आता?
येस मॅम.
आता आपल्याला पुढे जायचंय. ओके, आता हे बघा, मगाशी सांगितलं तेच इथे आहे, फक्त पुश ऑपरेशन करत असताना अगोदर काय केलं जातो, स्टॅक पॉइंटर हा 1 ने इन्क्रीमेंट केला जातो. सो स्टॅक पॉइंटर इज इन्क्रीमेंटेड बाय 1 and after that the contents of data register will be written onto the top of the stack. Okay, and at this time what is checked is if stack pointer is 0, then full is equal to 1. Check if the stack is full. जर स्टॅक फुल असेल तरच ही फुल नसेल तरच ही ऑपरेशन होणार. ओके, आणि मग ही ऑपरेशन झाल्यावर एखादा एलिमेंट तुम्ही इन्सर्ट केल्यावर स्टॅक वरती एम्प्टी नेहमी 0 करावा लागतो. ओके, अगोदर जर एम्प्टी तुमचा 1 असेल तर एलिमेंट टॉप वर इन्सर्ट केल्यावरती एम्प्टी 0 करावा लागतो. ओके, मग ह्याच्यामध्ये महत्वाचा पॉइंट काय लक्षात ठेवायचा आहे की प्रत्येक वेळेस पुश करत असताना तुम्हाला स्टॅक पॉइंटर अगोदर 1 ने इन्क्रीमेंट करावा लागतो आणि डेटा रजिस्टर मध्ये जो एलिमेंट प्रेझेंट आहे तो एलिमेंट तुम्हाला स्टॅकच्या टॉप वरती इन्सर्ट करता येतो किंवा राईट करता येतो. ओके, आणि जर तुमचा हे फुल असेल, स्टॅक फुल असेल तर मग मात्र तुम्हाला काय करता येत नाही, एलिमेंट इन्सर्ट करता येत नाही, कारण पहिल्यांदाच काय होतं, स्टॅक पॉइंटर इन्क्रीमेंट होत असतो. ऑलरेडी जर त्याच्यामध्ये 63 हा ऍड्रेस असेल तर तो 00 होऊन जातो आणि फुल तुमचा 1 इंडिकेट होतो आणि फुल 1 इंडिकेट झाला तर डेटा रजिस्टरवरचा एलिमेंट तुम्हाला स्टॅक वरती राईट करता येत नाही. ओके, अशा प्रकारे ही कंडिशन इथे चेक केली जाते. आता जर तुम्हाला स्टॅक वरून एखादा एलिमेंट डिलीट करायचा असेल, इफ यू वॉन्ट टू डिलीट फ्रॉम द स्टॅक, then what you have to do is you have to ensure that the stack is not empty. You cannot delete any item from the stack if stack is empty. Okay, so generally the pop operation is carried out. Pop operation is carried out in order to delete item from the top of the stack. एक minute, Okay, so we were discussing about the pop operation. That is, if empty is not equal to 1 or empty is 0, then and then only we can perform the pop operation. So in order to perform the pop operation, what you have to do is you have to move the data from the top of the stack. You have to move the data from the top of the stack to the data register. That is, you have to delete the element from the top of the stack and move it to the data register. And after deletion, you have to decrement the stack pointer by 1. So first you have to delete the atom and then decrement. So in push operation, what we have seen, first you have to increment and then push. Here you have to delete and then you have to pop and then decrement the pointer. Okay, and after decrementing the stack pointer, you have to see uh, if the stack pointer is 0. If the stack pointer is 0, then you can mark empty equal to 1. Okay, and full obviously is equal to 0 when you are going to delete some atom from the top of the stack. हे लक्षात आलं का डिलीट ऑपरेशनचं? अगोदर एलिमेंट डिलीट करायचा, मग स्टॅक पॉइंटर डिक्रीमेंट करायचा. स्टॅक पॉइंटर डिक्रीमेंट केल्यावरती स्टॅक पॉइंटर 0 आहे का बघायचा. स्टॅक पॉइंटर जर 0 असेल तर त्याचा अर्थ तुमचा स्टॅक एम्प्टी झालेला आहे आणि मग तुम्हाला एम्प्टी हा 1 मार्क करावा लागेल आणि फुल 0 मार्क करावा लागेल. अशा प्रकारे ही डिलीट ऑपरेशन स्टॅक वरून होत असते. ओके, लक्षात आलं हे मुलांनो? बोला. हा, आता पुढचा जो आहे पुढचा जो पॉइंट आहे तो आहे मेमरी स्टॅक. आपण रजिस्टर स्टॅक बघितला. आता मेमरी स्टॅक म्हणजे काय हे बघायचं. सो इन दिस पर्टिक्युलर फिगर यू कॅन सी the stack, and the stack is the standalone unit, and it can be implemented in random access memory of the CPU. So such type of stack is called as a memory stack. The stack which is implemented into the random access memory of CPU is called as memory stack, and stack which is implemented with the help of registers which are present within CPU is called as register stack. Okay, so now here if you observe the order of this stack, then you can observe the addresses are in the increasing order. The last element has highest address and the top of the stack has lowest address. So this order of address is exactly reverse to that of the register stack. Okay, now here you can observe this particular diagram. The memory unit is segmented. This segment is called as segment of the memory is called as stack segment. This segment is called as data segment, and this segment is called as program segment. So here you can store code, here you can store data, and here you can, this particular segment you can use as a stack when you are using function call or handling exceptions. Okay, or user can implement stack for any other purpose also. So there you have to define the area of the stack in your program. Okay, so this stack is pointed with the help of a register called as stack pointer. Data is pointed with a pointer called as address register, and the program segment of the memory unit is pointed with a register which is called as a program counter. So program counter indicates which next instruction to be executed. Address register will hold the address of the data, and stack pointer will hold the address of top element of the stack. Okay, so this is how the stack is implemented in the form of memory in RAM of the CPU. Otherwise, all remaining operations of the stack involved here is similar to that of register stack. But only here what you have to do is while inserting element onto the top of the stack, initially the stack pointer must be decremented by 1. This is exactly reverse to that of previous one. So when you are performing push operation, then before push operation, the stack pointer must be decremented by 1, and then only the push operation must be carried out. Okay. And during pop operation, after carrying out pop operation, your stack pointer must be incremented by 1. So this is exactly reverse to that of your register stack. Here you can observe SP is equal to SP minus 1, and then contents of data register will be added onto the top of the stack. Okay. And during pop operation, the data element from stack memory will be moved to data register, and thereafter stack pointer will be incremented by 1. So here also the stack is full or stack is empty is indicated with help of software. Okay. So there is no hardware check. There is no hardware check for stack overflow and underflow. Overflow means full stack condition. Underflow means empty stack condition. Okay, so these two conditions or these two limits are software controlled limits and not hardware control, like that of which are shown in your register stack organization. So these are the two differences where the difference lies between register stack and memory stack. Okay, so are you clear about this?
Yes, ma'am.
In case of memory stack, stack grows by decreasing the memory address. In case of register stack, stack grows by increasing address. So this is the main difference. There is advantage of memory stack as it is software implemented stack. What is advantage is that CPU can refer to it without having any specific address known to it. Okay, so this address will be automatically updated into the stack pointer because a separate stack segment has been defined. So this is the important advantage of the memory stack. Okay, so this is all about the stack organization. Now let us go to input output organization. Let us go to input output organization. Now, what is input output organization? Arrangement of input output devices in a computer system. It's called as input output organization. So why this organization is necessary? Because to use the computer efficiently, to improve the performance of computer, the way in which input output devices organized, it matters, and the way to handle these devices must be devised to have efficient way of operation. So such organization of a computer system is called as input output computer system. And input output devices are also called as peripheral devices. So you understand this. Okay. Can you give me some examples of input output devices which are connected to the computer? Yes. Yes, can you give me example of input output devices which can be connected to computer? Tell me, speak up. बोला मुलांनो पटकन. बोला आहात ना? इनपुट आउटपुट डिव्हाइसेसचे एक्झाम्पल सांगा. साक्षी.
Yes, ma'am.
बोला इनपुट डिव्हाइसेस कुठले वापरतो आपण कम्प्युटर मध्ये?
Scanner.
हा, कोणते इनपुट
Scanner.
डिव्हाइस? हा, बोला पटकन. अथर्व, इनपुट डिव्हाइसेस कुठले आहेत?
राउटर.
अरे इनपुट डिव्हाइसेस कीबोर्ड, माऊस, मायक्रोफोन, स्कॅनर, हे सगळे इनपुट डिव्हाइसेस आहेत कम्प्युटरचे. आणि आउटपुट डिव्हाइस कोणते? प्रिंटर, मॉनिटर, स्पीकर, हे सगळे आउटपुट डिव्हाइसेस आहेत, हे लक्षात ठेवा. ओके. And memory is also, secondary memory is also treated as a peripheral device. Okay. So here you can see the way in which these peripheral devices are connected to the processor. They are connected with help of addresses, buses, data bus, address bus, and control bus. Okay. And between this processor and your input output device, there is an element which is called as interface. With help of interface only, every device, every input output device is connected to the processor. Without interface, we cannot connect any device to the processor. Okay. So this is the way in which input output devices are connected to your processor with help of interface. Okay. Now why there is need of interface in between? Why there is need of interface in between processor and input output device? Can you tell me? असं समजा एक माणूस आहे, त्याला फक्त फ्रेंच बोलता येतं, आपल्याला फ्रेंच बोलता येत नाही, आपल्याला फक्त मराठी बोलता येतं. या केसमध्ये तुम्हाला काय गरज पडेल सांगा मला. असं समजा अथर्वला फक्त मराठी बोलता येतं. ओके. आणि साक्षी आहे, तिला फक्त फ्रेंच बोलता येतं. मग ह्या दोघांमध्ये कम्युनिकेशन कसं होणार?
ट्रान्सलेटर.
ट्रान्सलेटर, बरोबर आहे. एक ट्रान्सलेटर वापरावा लागेल तुम्हाला आणि त्या ट्रान्सलेटरला दोन्ही भाषा यायला पाहिजेत. मग साक्षी जे काही फ्रेंच मध्ये बोलते, तो ट्रान्सलेटर ते मराठीमध्ये कन्वर्ट करणार आणि मग अथर्वला सांगणार. बरोबर. मग त्याचा आन्सर अथर्व जे काही बोलतो मराठीमध्ये, त्याचं कन्व्हर्शन तो ट्रान्सलेटर फ्रेंच मध्ये करणार आणि तो साक्षीला सांगणार. बरोबर आहे की नाही? म्हणजे ट्रान्सलेटर लागतो ना मध्ये. जर दोघांना एकमेकांच्या भाषा येत नाही आणि त्यांना कम्युनिकेट करायचं आहे, तर तुम्हाला मध्ये एका ट्रान्सलेटरची गरज पडते. बरोबर आहे. तसंच सेम तुमच्या इनपुट आउटपुट डिव्हाइसेसच्या संदर्भात होतं किंवा पेरिफेरल डिव्हाइसेसच्या संदर्भात होतं. आता वेगवेगळी कारणं आहेत की इंटरफेस मध्ये का वापरावा लागतो. ओके. सो फर्स्ट we are going to discuss this various reasons why we need interface in between that of your processor and input output device which is connected to the processor. The first reason, as you can observe from the screen, is that the peripherals generally they are electromechanical or electromagnetic devices. Okay. And your CPU is a digital device. Okay. So what you can observe is the manner in which the peripheral device operates and the manner in which your computer system operates. It is totally different. Okay.